This is Geometry, Unit 9, Day 6, working on coordinate proofs. We're looking at a parallelogram. Parallelogram is a quadrilateral with both pairs of opposite sides parallel. A parallelogram can be written using this symbol. The symbol here is a parallelogram. So parallelogram, PQRS. There is not a symbol for a rectangle or a square. Obviously there's a figure that we use in front for a triangle. That's the most common. A parallelogram PQRS, we have segment PQ is parallel to segment SR, and also QR is parallel to PS. We're going to assign coordinates to our parallelogram, and then we're going to show that this is in fact a parallelogram. So we have our point at the origin. We have our coordinate that would represent being on the x-axis. We typically call A0. Notice that x is not on the y-axis, so it's over and up. When it's a parallelogram, this point has no influence by what's happening here on the x-axis, so we would use two separate letters, BC. But this fourth point is very much determined by what's happening by the others. It's at the same height as the y value here, and notice that if you go straight up, this distance here is going to be the same distance, which is A, and the extra distance that it takes to line up here is going to be the same distance that was taking to get over to your point there. So that would be B. So that's why this is called A plus B. It takes the A distance plus the additional B distance to reach to this coordinate. So if those are our values for the coordinates, we can now show that we have a parallelogram. We're going to show that we have two sets of parallel sides. So first we're going to talk about the slope of xw. That is c minus 0, which is y2 minus y1. Recall that slope itself is calculated by y2 minus y1 over x2 minus x1. So y2 minus y1, x2 minus x1. So that would be our slope. That would be the rise, which you're going up a height of c, and then your run, you're going over a length of b. Now we're going to look at the slope of yz. That has a c value of, or a y value of c and a y value of 0, an x value of a plus b, and an x value of a. So y2 minus y1, x2 minus x1. Notice that the positive a and the negative a would cross out. So that's going to leave you with c over b, which shows that these two values are the same. If those are the same, then we have xw being parallel to yz. Because our slopes are the same, we know that the two lines are parallel to each other. They're going in the same direction with the same slope. We're now going to look at the other two lines. Those two lines are horizontal, so we should already have a pretty good guess on what their slopes would be. What do you think the slope of a horizontal line should be? We're going to take the slope of xy, and we take the y2 minus y1 over x2 minus x1. So that becomes 0 over a. 0 over anything other than 0 is going to have an answer of 0. We're going to compare that slope with the other horizontal line, and yes, you would suspect that every horizontal line has a slope of 0. So we get 0 minus 0 and a minus 0. We're getting the same 0 as our slope. It really doesn't matter what the denominator is as long as the top is 0, but in this case even the denominators match. So those two are the same. We could say same over here too. But because they're the same, we know that our xy is parallel to wz. So this shows that we have two sets of parallel sides. Next, we're going to look at the coordinate proof to show that the following properties are true. Both pairs of opposite sides are congruent. That's a property we've learned about with parallelograms. So we're first going to look at the length of xw. So using our distance formula, we know that x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's the formula for distance. So we're going to use our square root. We're using x and w. So our x's are b minus 0 and c minus 0. That gives us a result of b squared plus c squared. That can't be simplified any. You can't take the square root if there's a plus. You can take the square root of b squared, you can take the square root of c squared, but you can't take the square root of b squared plus c squared. Plus or minus for that matter, you wouldn't be able to take the square root. So now we're going to try to take or calculate the distance of side yz, which is the same idea. You take your x's, so x2 minus x1 plus y2 minus y1, and here the a's would cross out because you have a positive a and a negative a. That leaves us with b squared and c squared. So notice that they're the same. If they're the same, then we know that xw has to be congruent to yz. Same distance gives us congruent segments. So let's look at the next distance. We have the distance for xy, which is x2 minus x1 plus y2 minus y1. So the b's cross out, the c's are going to cross out, so we're getting a distance of a squared plus 0 squared. It's just a squared, and you can actually take the square root of a squared, which leaves us with just a. WZ is going to be very similar to that. You have the a value, which is your x2 minus your x1, and your y2 minus your y1. So the zeros cross out, and you get a squared, and the square root of a squared is just a. So these are the same. So if those are the same, then we're going to have XY congruent to WZ. We have two sets of parallel sides. Next, we're going to prove that the diagonals bisect each other. So let's think about what those words mean. Prove means that we're going to give evidence with some formulas. Diagonals. What are diagonals of a polygon? Diagonals are segments that connect non-consecutive or non-adjacent vertices together. So that would be considered a diagonal for this parallelogram. What does bisect each other mean? That we would be looking for the two diagonals to cut this side in half and to cut that side in half. Notice that I use a different number of tick marks because the halves may not be the same for each segment. Now, how do you get to the half? What is that location called? It's a midpoint. So we're going to look for the midpoint for each of these segments. So we're looking for the midpoint for WY. And that midpoint is going to be, take the x's, x1 plus x2 over 2, and y1 plus y2 over 2. That leaves us with an a plus b over 2 and a c over 2. So that's our midpoint of WY. Now we're going to look for the midpoint of XZ. XZ, so we have our X2 and Y2, X1 and Y1. So X2 plus X1 over 2, 0 plus C over 2. So again, that is A plus B divided by 2 and C divided by 2. So notice how they are the same. So both those diagonals have the same midpoint. The same midpoint means that these segments bisect each other. Next, we're going to find the lengths of the diagonals of the parallelogram. What do we suspect that that means? What does length mean? How do you find the length of something? I'm not going to use a ruler. So we come up to our shape. Length is the same thing as distance. So we're going to calculate the distance of one diagonal and the distance of the other diagonal. We're going to see if their distances are the same. What do you suspect is going to be true about the distance of each diagonal? One of them is clearly longer than the other. WY is much longer than XZ. That's not true for every parallelogram, but it is true for each parallelogram in this format. There are other parallelograms. Rectangles are parallelograms. They hold all the same properties. A rhombus, a square, those are all different types of parallelograms. But here, for just a normal parallelogram, we're going to look at the lengths of their diagonal. So we're going to do the distance formula for WY. So that's going to be the square root of A plus B minus 0 squared plus C minus 0 squared. That leaves us with A plus B squared and C squared. That's as much as we can simplify that. There's nothing you could do here. You could write it with two separate A plus B and A plus B. You could write it twice and then FOIL that together. But you cannot distribute this through. It's not A squared plus B squared. That's not the same thing. So we'll just leave it in this format. You can't take the square root of any of this because of the plus. Next we're going to look at XZ. XZ, we're going to say A minus B squared plus 0 minus C squared. That gives us A minus B plus C squared. When you're squaring this binomial, that doesn't affect the minus in between, so that stays the same. But if you have 0 minus C, so that really leaves it with just negative C squared. You're squaring the negative, you're squaring the C. Square the negative, you get a positive C squared. So that just leaves it with C squared. Notice how these are different. Those two signs are different, so that means that WY is not congruent to XZ. So if it's not congruent, then the diagonals are not the same length. It's not congruent, the diagonals are not congruent in all parallelograms. There are some, and when we would use those coordinates, you might show that those diagonals were the same length. But here, with a parallelogram in this format, they are not congruent. The diagonals are not congruent to each other. Example number 4, we're working with a rectangle. This would be A comma 0 because it's on the x-axis. This would be 0 comma B. 0 means it's on the y-axis. B means it's up a different amount than A. We're over A and up B. That's our rectangle. We're going to show that this rectangle is a parallelogram. How do you show that this is a parallelogram? We're going to show that we have two sets of parallel sides. So we're going to start with the slope of XW. So that's y1 minus y2 over x1 minus x2. That's b over 0, which is undefined. Now it wouldn't have mattered if I said y2 minus y1, x2 minus x1. That's typically how you'd say it. The point is that the denominator would be 0 regardless. If the denominator is 0, then your slope is considered undefined. It's vertical. It's going straight up and down. That's undefined. We're now looking for the slope of YZ. So that's b minus 0 over a minus a. b over 0, which again is undefined. Since they both have the same undefined slope, they are considered parallel to each other. W, let's call it xw, doesn't really matter, but xw is parallel to yz. That's because both of these are the same. They're both considered undefined. They're both vertical. That makes them both parallel to each other. As long as they're the same, they would be parallel. Now we're going to look at the slope of xy. We're going to say b minus b and a minus 0. That's 0 over a, which is 0. Now we'll look at the slope of wz. We get 0 minus 0 and a minus 0. Again, we're getting a slope of 0. As long as the numerator is 0, we know that the fraction is 0. Just as long as the denominator is not 0. That would mean undefined. These are the same. If they're the same, then xy is parallel to wz. As long as they have the same slope, the two segments are parallel. Both of these slopes are horizontal. They both go right to left. So that makes their slopes 0. They're flat like the floor. 0 slope. Vertical is undefined. Slope like the wall would be undefined. Next we're going to look at a rectangle and about its diagonals. So we're going to look at xz. xz is a diagonal. So we'll use our distance formula. A minus 0 squared plus 0 minus b squared, square a, square negative b, which makes b squared, and that can't be simplified. Then we have the other diagonal, yw. Typically you don't put a bar when you're talking about length. So that's going to be